Okay, so that's natural enough. You could say, well, I mean, how are we going to do that? Talk is cheap. And here's the really clever idea. Which is we're going to do it recursively. Okay? So implementation, we will implement this pivot in order to accomplish that goal, to find not the median, but a surrogate of the median quickly. And the way we're going to do it is by recursively computing a median of medians. Now, what on earth could I mean by that? Let me explain. So now I'm going to talk about how we're actually going to implement step one. Okay? So what do we do? All right, so talk about it sort of conceptually, and then I'll summarize it with some pseudocode when we're done with the discussion. Okay? So we're going to take this input array A, and we're going to group it into we're breaking it into groups of 5. Okay, so elements 1 through 5. Remember, it's unsorted. Okay, so these elements could be anything. We're just going to look at the first 5 elements in the array, the next 5, and so on. Of course, if the length is not a multiple of 5, we have this one visual at the end. 5 elements. Now, what we're going to do might seem very strange. It's a good idea, which is to sort each of these groups of just 5 elements. Okay, so we take the first 5 elements of the array, which could be anything, it's an unsorted array, and we make them so that they're in the correct relative order to each other. Similarly, the elements in 6 through 10 of the array, we sort just that little block and get them in the right relative order with respect to each other, and so on and so forth. Group of 5. Okay? So sort each using, let's say, merge sort. Okay? Now, what you might be concerned about is, wait a minute. We're trying to get a linear timeout. We know then n log n. And now somehow we're calling merge sort in the middle of a supposedly linear time algorithm, right? But we're only on these tiny groups, these groups of only size 5, right? We're not sorting the whole array. We're just sort of getting these little mini sorted regions, all right? So there's hope that this doesn't take n log n time because we're not sorting the whole array. We're just doing these little mini sorts, and in fact, we're not. So you'll recall in lecture number 2, we talked about how many operations merge sort requires, and it was times n log n. The input size is 5. Right? We're only feeding in 5 elements at a time in the merge sort. Okay? So by lecture number 2, takes at most 6. And again, we have an m log m plus m, where m is going to be 5 for us. Yeah. And, log 2 of 5, let's just among friends call that 3. And that'll give us a bound of 120 or something. 3, 4, 20, yeah. Per group. Groups. Which is a linear amount of work for all groups. The fundamental underlying theme in this linear time selection algorithm is it's related to sorting, but we can't sort the array. That's time. So let's just keep doing various types of partial sorting that we can get away with in linear time. Okay? Stitching different partial sorting together in the array will actually solve the whole problem in only linear time. So this is one of those notions of partial sorting. Just sort each of these groups of 5 separately. The n log n is not n, it's only linear work. Okay? Now what's the rest of choose pivot? Okay, so this is the first thing we do. Now for each of these sorted groups of 5, we look at the middle element. Okay, so after this sorting, we look at the third index of the array. That's the middle element of the first 5. After sorting 6 through 10, we look at what's in index 8. That's the middle element of the second block, and so on. So we look at the corresponding n over 5 medians. All right, so by which I mean just the middle element right, n over 5, that's less than n. All right, our original input was n. So now we have n over 5 of them. We can legitimately recurse on these n over 5 middle elements. Okay? Of these n over 5 middle elements, and this is what we return as our pivot.
Just to double check, is there going to be a neutral recursion going on?
Yeah. So let me write the rest of the pseudocode, okay? Because it's a little bit of a mind bender at first. All right. Maybe even not just at first.